Heinemann Higher, Chapter 6 in Differentiation, Exercise 6S, the mixed questions at the end, number 18 in the section on optimisation. Now, question 18 says this: staff in a hotel are paid £6 an hour. If the staff is understaffed, if the hotel is understaffed, the lost profit is given by this expression 216 upon x, where x is the number of employees. What staffing level will minimise optimisation? It's the same as stationary values. Just like finding stationary points on curves. Don't panic when you see these. We'll minimise the total staffing cost. So I want the total staffing cost. So I'll call that C of x again because it wasn't given a name. So what would it cost to staff this hotel? Well, however many staff you've got, you have to pay £6 an hour. So that's going to cost 6x. And the lost profit, which would be an additional cost then, the lost profit would be 216 over x. That would be the cost of running the hotel per hour for X staff, and it wants to know what staffing level would minimise this cost. Well, first thing would be differentiate it. But before you can differentiate it, let's get that rewritten in a suitable form. There it is, index form. Now differentiate it, so c dash x. Well, that'll just be 6, and that'll be minus 216x, 1 over the power, negative 2. I'll put that back as over x squared because I know I'm going to use it. Now, I'm looking for an optimum. I'm looking for an optimum value here, which means that I'm only going to get an optimum value if this expression for the derivative is ever equal to 0. That is, if 6 minus 216 over x squared ever equals 0. Right, fractions, get rid of them. Multiply them by x squared. Fair enough, because x wasn't going to be 0. So that's going to be 6x squared minus 216 equals 0. Now, it's not a case of factorising this case, only one mention of x, so you can solve it linearly. So that's just a case of get rid of that, and get rid of the squared. So 6x squared is going to equal 216. So x squared is going to be divided by 6, that'll be 36. So the x is going to be plus or minus 6. But since we're talking about real people in a positive universe, that means x is going to equal 6. Now, one other thing I suppose I should do in this case is justify whether that's a maximum or a minimum cost for this optimum. Is this the most it'll ever cost them, or is this the least it'll ever cost them? So I will make up a little nature table here just to justify that, even though the question said minimises. So we'll say, well, something happened at 6. When x was 6, something happened to the rate of change of the cost. We'll just pick something before it and something after it. Well, before it I could choose 1, after it I could choose 10, at it was 0, and then just put it into this expression here. So 6 minus, and if x was 1, that would be an awful lot, that's negative. And if x is 10, that's divided by 100, it's only 2, 6 take away 2, that's going to be positive. So it is indeed going to be a minimum cost. Don't mind wrote all that out. Right, so I could finish it off with a sentence. So, the minimum, hardly readable, wiggle, 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 the minimum cost, you get a minimum cost when x equals 6. Although we could have written when there are 6 staff. There it is, an optimisation question with nothing to be scared of. It's just like finding a stationary value and justifying it.